You have to be able to divide by a linear binomial. Is this a linear binomial? Yes. Has it got two terms? Yes. Now, some of you are going to say you can't do it because there's a 1 in front of the x, a 5. You get divided by 5, and you get divided by 5. There won't be a 5 in front of that x. And now what we're going to do is we're going to do 3x squared plus 11x plus 4, and we're going to be dividing it by x plus 4 instead. We're going to do the same problem, but in different close. If you are dividing by a linear binomial, you can do the problem. You just may have to tweak it. And some are going to say, well, what happens if they're not all divisible by 5? I guess you got fractions. So 3x squared plus 11x plus 4 gets divided by x plus 4. You should be putting negative 4 here because whatever this is should be the opposite right here. 3, 11, 4. I would suggest putting a little bar underneath the 4 because this is where you're going to have your remainder. So now I'm going to go through the steps without doing the long division. The 3. I just brought it down to the bottom. The first number is always the same as the first number here. So if negative 4 gets multiplied by 3, you get negative 12. Now what did I say we end up doing here? When you go down the column, you always add 11 plus a negative 12, which is negative 1. And then you repeat the process over and over again. So what did I say you do with the negative 4 and the negative 1? You multiply. That's going to put us here at 4. Now you're probably thinking, oh, 4 is going to cancel. No, because if you add them together, you get 8. It is not a factor because it is not 0. Now you just have to decode the situation. Now, what did I say here? If this is 3x squared, then this is just going to be 3x. So if this was the x, if this is the linear, this is the constant. So then you just go minus 1. What did I say this was? Remainder. But we wanted you to write them as fractions. Now, let me just give you a long division example. Okay, but it won't be like the one I gave you. This is much simpler. 3 goes into 7 twice, with the remainder of 1. But what is division? Division is actually a fraction. 2 and 1/3. There's your remainder right there. So what we're going to do is we're going to do the same thing here. Your remainder is 8, and we're going to put it over x plus 4. Now one could argue we started with 5x plus 20. But if you want to do that, then I'm going to have to force you to multiply the top by 5 and the bottom by 5. And do you really want to have to do that extra work? Nah, we'll leave it just the way it is. But here we go. X is being divided, is this being divided by x minus 2? What's going to go into the little bracket here? 2, 1, negative 2, 0. You see a quadratic term? 4th degree. 3rd degree, no 2nd degree. You've got to put that in there. That's the x squared that's missing. Then comes 9 and then 20. All right, let's go through the process. What do we do with the 1? Just drop it. Multiply it by 2, put it here, and then we add them. Take the 0 and multiply by 2, which is 0, which conveniently also works out to be 0. Okay? 0 times 2 is still 0, but 9 plus 0 is 9. So 2 times 9 works out to be 18, and you get a remainder of 38. Some people are better off writing from right to left. Like this is the remainder, so immediately put 38 over x minus 2. And then realize that's got to be the constant. This is linear x. This is quadratic x squared, which makes this 3rd degree. And then very simply, is this a factor? And the answer is no. We got a new problem here, example number 4. How do we set this up? What did I say you have to be able to divide by? Is that a linear binomial? No. Can't be done synthetically. Guess the only way you would have to do this. Long division. Is this today's lesson about long division? Then we're skipping the problem and moving on.